Good evening dear students. Today I am going to discuss about complementary function and particular integral first form, that is e power ax. Listen carefully, these both are easy and important for you. Here first for example, given differential equation is d square y by dx square minus 5 into dy by dx plus 6y, that one is equal to 0. It is given differential equation. In this q of x not there, q of x equal to 0 is there, that is why here for this complementary function is the general solution. For the given differential equation, complementary function is the general solution. Okay, here for the first given equation, to find general solution for this differential equation, here first given equation we should write in the operator form. Operator form means d by dy by d by dx, d square by dx square, d cube means d cube by dx cube, like this we can put. Here it is said to be operator form of the differential equation. Here that is we did here, that is only we written here, here it is of the form f of d into y, that one is equal to 0 here. Then here auxiliary equation, what is the auxiliary equation? F of m is equal to 0 means auxiliary equation is the algebraic equation for the given differential equation. Algebraic equation means just we need to replace d by m in the given differential equation. Here that is only we did here. D by m means d m square minus 5m plus 6, that one is equal to 0 we return. Okay, here for this we need to find the roots. To find roots you should use calci, don't solve, simply use calci and find the roots. That roots are here for the given for the above equation, for the above algebraic equation or auxiliary equation, roots are 2 comma 3. 2 comma 3 means these roots are real and distinct. These roots are real and distinct. Okay, here real and distinct means what is the general solution? Already I given general solution in first class only. Okay, what is that one? Here these are the m1 m2 values. For example, m1 m2 values means c1 into e power m1x plus c2 into e power m2x. In place of m1 we need to put 2, in place of m2 we need to put 3. That is here y is equal to c1 into e power 2x plus c2 into e power 3x is the required solution for the given differential equation. Okay, it is the complementary function. Okay, here complementary function only general solution for the given differential equation, because q is equal to 0 is there. Now next one is what here it is solution when given roots are real and distinct. Next, what about next one? Next one is here it is the given differential equation. Given equation can be written as like this, that is operator form. I am writing here. I written operator form only. Here after that one, here x is the dependent variable, here t is the independent variable. Here at last x equal to, here x equal to, you can get function of t, that is the solution. How we can write, that is we can see. Here it is the operator form, that is first I written that one. Next after that one, here it is of the form f of d into y. Here f of d value you know, this one only. Here auxiliary equation we should write, that is f of m is equal to 0, m square minus just replace d by m square minus 6m plus 9, that one is equal to 0. Here it is of the form a minus b whole square formula, a minus b whole square formula. Here then a in place of a, m is there, in place of b 3 is there, m minus 3 whole square, that means here 3 repeated how many times? 2 times. It is real and repeated. Real and repeated means here what is the solution? The required solution is x equal to, always dependent variable is equal to function of independent variable, that is c1 plus c2 t into e power 3t e power 3t. It is the required solution for the given differential equation. Next, what about next one? Here next one is solve differential equation y double dash minus 4 y dash plus y is equal to 0. It is a differential equation they given. Here this differential equation can be written as like this: y double dash means d square y by dx square, y dash means dy by dx, y only. Here for this we should write the operator form. Here operator form I written. After that one, here it is of the form f of d into y, that one is equal to 0. F of d is equal to, what is f of d, I written that one. Next auxiliary equation is f of m is equal to 0, that just we need to replace d by m in the above operator form, that is only we written here. We need to find roots by using calci, no need other one here, or otherwise here you can use formula minus b plus or minus under root b square minus 4ac by 2a. Okay, here use this formula to find roots. Here after that one, here whatever here what you got here by using calci directly you can get these two roots. These two roots are the real and distinct only, no, these are not complex roots, these are not complex roots, complex conjugate roots. Here these are the real and distinct, that is why y is equal to c1 into e power m1x plus c2 into e power m2x, means c1 y is equal c1 into e power 2 plus root 3 into x, c2 plus c2 into e power 2 minus root 3 into x. That solution we written. Here it is the required solution when roots are real and distinct, Okay, here next, what about next one? Next one is next one more equation is they given. It is also differential equation. Here this here it is directly they given in operator form. Okay, next, what about next one? Here in operator form, f of d, what is f of d? D square plus d plus 1. Here after that one, the auxiliary equation we should write. F of m is equal to 0, that is just to replace d by m. Then after that one, m square plus m plus 1. Here m is equal to minus 1 plus or minus under root b square minus 4ac by 2a. Here for that by using that one, here or directly you use calci and write these roots. Here minus 1 by 2 plus or minus I root 3 by 2 you can get. Here that is, these are the required roots for the above algebraic equation or auxiliary equation. For this general solution is, what is the solution for this? For complex roots, what is the general solution? Complex conjugate, these are all these here. Then e power, here a value is minus 1 by 2, b value is root 3 by 2. Here y is equal to e power minus 1 by 2 x into c1 cos root 3 by 2 x plus c2 sin root 3 by 2 x. It is the general solution. It is a complementary function when roots are complex conjugate. Next after that one, d square plus 4 whole square, it is a given differential equation, they given directly in operator form. Okay, here what is f of d, you know. Here for that auxiliary equation I am writing, that is f of m is equal to 0, just replace d by m. Here I am writing like this. Here m square plus 4 into m square plus 4. Here m is equal to what? M is equal to plus or minus 2i you can get. Here when any one you can take. Here m square plus 9 means m is equal to plus or minus 3i. Here m square plus 1, that one is equal to 0, m is equal to plus or minus I. Like this you can write the roots. Here these roots are the these two pairs are equal and conjugate complex parts. Then here what is a not there for this, so a is equal to 0, b is equal to 2 you have. So the required solution is generally, here two pairs are repeated here, then required solution is e power a into x, means 0 into x, c1 plus c2 x into cos 2 x plus c3 plus c4 x into sin 2x, it is the required solution. E power 0 x means that is, you know, that is 1, here 1 into c1 plus c2 x into cos 2x plus c3 plus c4 x into sin 2x, it is be written here. After that one, rules for finding particular integral. Rules for finding particular integral. Rules for finding particular integral, in that first method is e power ax. Here e power ax method only. Here sin hax or cos hax means, for sin hax and cos hax also we should write the exponential formula. What are the formulas? Sin hax is equal to e power ax in e power ax minus e power minus ax by 2. Cos hax means e power ax plus e power minus ax by 2. Okay, for if we get these two functions also, in that case we should write these two formulas and we should apply e power ax method only. Now particular integral general form is this one, that is 1 by f of d into q of x. What is q of x? E power ax. Here put d by a, put d by a. Here by putting d by a in f of d, if we got non-zero value, it is the required solution. If we got non-zero value, that means f of a not equal to 0, then it is the required solution. Other than, next, sometimes we may get f of a is equal to 0, f of a is equal to 0, then here it is a failure case, pi particular integral is equal to x into, first we should take, if we got f of a is equal to 0, immediately x we should take left side. Here 1 by here differentiate f of d with respect to d, then what you can get? F dash of d you can get, here into e power ax, you should write like this only. After that one, here replace in f dash of d, replace d by a again, what you can get, you should observe here. By putting d by a in this, if we got non-zero value, then we can stop here only, it is a required solution. Other than, here if f dash of a is equal to 0, then particular integral is equal to, here again differentiate f dash of d with respect to d, then what you can get? F double dash, we should take x left side, already we taken one x, one more x we should take, again differentiate this one with respect to d, f double dash of d you can get into e power ax, then here x square by f double dash, here again replace d by a, if we got non-zero value, then it is the required solution, we can stop here only, and so on. It is the procedure for e power ax method, here we can discuss small example. Now here first given equation, here what is the given equation? It is the given equation, given differential equation. Here given differential equation we can write in operator form, that is d square minus plus 5d plus 6 into y, that one is equal to e power minus a minus x. Here after we written in operator form, it is of the form like this, f of d into y, that one is equal to q of x, then f of d is equal to what? D square plus 5d plus 6. Here q of x equal to what? E power minus x. Here auxiliary equation, what is the auxiliary equation? Same procedure, auxiliary equation is f of m is equal to 0. F of m is equal to 0 means, here just we should replace in place of d, in place of d put m, okay, just replace d by m in the f of d, then what you can get? M square plus 5m plus 6, use calci to get roots, here minus 2 minus 3 you can get, these are the real and distinct, distinct roots we got, right? Next, if we got real and distinct, then you know the general solution. What is the solution? c1 into e power minus 2x plus c2 into e power minus 3x, that is you got. We here it is a complementary function completed. Okay, complementary function completed. After that one, particular integral form is pi is equal to 1 by f of d into q of x. 1 by f of d means 1 by d square plus 5d plus 6 into e power minus x. Replace here, what is the x coefficient? X coefficient is minus 1, so just replace d by minus 1. D by minus 1 means minus 1 square plus 5 into minus 1 plus 6. Here what you can get, 1 plus 6 7, 7 minus 5 2. Okay, e power minus x by 2 is the particular integral. Hence the complete solution is y is equal to complementary function plus particular integral. Here y is equal to c1 into e power minus 6 plus c2 into e power minus 3x plus e power minus x by 2. It is the required solution for the above example. Here next, what about next one? Here one more next question is d cube plus 3d square plus 3d plus 1 into y, that one is equal to e power minus 6. It is the given differential equation. It is an operator form only, they given directly. Here the in this it is of the form f of d into y, that one is equal to q of x. What is f of d? F of d is equal to d cube plus 3 square plus 3d plus 1. Here that is we written. Here q of x equal to, you know. Here after that one, the auxiliary equation f of m is equal to 0. Here replace d by m. Here m cube plus 3m square plus 3m plus 1, that one is equal to 0. Here it is of the form a plus b whole cube formula. So m plus 1 whole cube I written. Here m plus 1 whole cube means m 1 minus 1 3 times you can write, that is m is equal to minus 1 minus 1 minus 1. Here that is we written 3 minus 1s we written here. These are the real and repeated. Here after that one, c1 here real and repeated means c1 plus c2x plus c3 x square into e power minus x. It is the required complementary function. Here after we get complementary function, we can go for the particular integral. Particular integral is 1 by f of d into q of x. It is the general form of the particular integral. After that one, 1 by f of d means we know d cube plus 3d square plus 3d plus 1 here into e power minus x. Here what is the x coefficient? X coefficient is minus 1. Just replace d by minus 1 in the denominator. In the denominator we need to put by substituting d by minus 1, what you can get? 0. 0 means that is a failure case. That is a failure case means if we got failure case, then immediately we should take x left side. Differentiate denominator with respect to d. Means here like x. Here d cube differentiation means 3d square. Here next to 3 into d square differentiation is 2d. 2 into 3 means 6d plus 3d differentiation with respect to d, and d differentiation with respect to d means that is 1 plus 0. Here after that one, again we should try again replace d by minus 1. D by minus 1 means minus 1 whole square, 3 into minus 1 whole square, 6 into minus 1 plus 3. Here 3 plus 3 6 minus 1 minus 6 0. Okay, again we got 0 here. So again failure case means next one more x we should take on left side. Already we have 1x, one more x we should take. Again differentiate with respect to d. 6d plus 6 into e power minus x. Okay, here again we need to put d by minus 1. Here by putting d by minus 1, minus 6 plus 6 we are getting. Again we are getting failure case. So one more x we need to take. Already we have 2x terms. Here one more x we need to take. That is next denominator differentiation with respect to d. 6 into d differentiation with respect to d is 1 plus constant differentiation is 0. So 1 by 6 into e power minus x. Here then what about next one? At last particular integral is equal to x into x means x cube by 3, x cube by 6 into e power minus x. Here the complete hence the complete solution is y is equal to complementary function plus particular integral, that is y is equal to c1 plus c2x plus c3 x square into e power minus x plus x cube by 6 into e power minus x. It is the required solution for the given example. I think you understood. These are the most important procedures for these two methods. One we discussed normal method, another one we discussed failure case method. Okay, these two are most important for you. Thank you.